Hi everyone. This is LeetCode Weekly Contest 513. Maximize pair strength using GCD. What's it defined as? Nums I times nums j divided by dat. Um, 15, 12, and 1. Okay. All right. Next question. Next problem. Count subrows of even odd ratio. Given an integer array nums and two integers a and b. For a subarray, let x be the number of even elements and y be a number of odd elements. The ratio is defined as x over y. Subarray consider valid if y is greater than 0, and x divided by y is less than or equal to a divided by y, a divided by b. Determine the number of valid subarrays in nums. So you can do n squared. Um, x times b. X times b is less than or equal to y times a. Seven, 3, and 0. All right. Next one. Count unfinished tasks after each shift. You are given two integer arrays, tasks and shifts. Task I represents the time required to complete the 5 task. Shift J represents the amount of time available during the J shift. All tasks must be processed in order from left to right. Carry over. If a task is not completed during a shift, processing continues from the same point in that task during the next shift. Restart. If all tasks are completed during a shift, the shift ends immediately. Any unused time in that shift is discarded and the next shift begins again from task 0. Task is unfinished if it is not being fully completed. This includes a task that is currently in progress. Alternate integer array answer, where answer j is the number of unfinished tasks immediately after the j shift. What does this mean? So let's see. Shift 0, 1 plus 4 plus 4 goes 9. 0 unfinished task. The shift has time 0 time 1. So that's 0 completed, 2 finished task. 5 task 1 time 4, so task 1 is completed. 9 and okay. Full tasks are completed on 0 unfinished tasks. Partially completed. 1 plus 2 equals 3. And processing restarts from task 0. That's 1. Okay. Um, for every shift. Okay. Auto keying shifts, we have our pointer I. Should be, yes. Int time equals 0. If time, let's see, int need equals tax I minus time. If t is greater than or equal to need, I plus plus, and time is equal to 0. If I is equal to n, then insert a pushback 0, and you can continue, right? Otherwise, if I is not equal to n, you can just keep going. T minus equal to need. Over here, um, time. So time plus equal to t, and then insert a pushback n minus I. Okay. So now time is always equal to 0. Over here we can continue. Yeah, continue. So now time is always equal to 0, and we can just um use a prefix sums. Okay. So int okay, or long okay. It should be equal to ref I plus t. Okay, so that is the final okay time. We can lower bound, right? We can do a lower down. Auto it equals ref that. Um, should you can do a up bound instead. Okay, if it is equal to ref dot end, I will be equal to 0. I is equal to 0. Once I is equal to 0, then time will be also equal to 0, and insert dot pushback 0. Otherwise, it will be ref it. That's how much we're at. That's how much we can do. So it. So I will be equal to it minus ref dot begin, and time will be equal to this minus okay. Enter dot pushback n minus I. Return answer. 0 to 0. Again, I'll put I at each time. Yeah, after the first one, I should be 0. And then after the second one, I is 1. After the third one, I became 0 again. Actually, I don't think we need all this casework. I think we already took care of that. IT is equal to this is- I think we should do lower bound instead. Yeah, lower bound. 0, 2, 1, 0, 1, 0. So we got something wrong over here. After 20, it'll be 0. After 4, it should be 2. Okay. 0, 2, 0, 0, 3, 1. I got 2, 3 now. 0, 1, 2. After 1, we should be at 1. Yeah. So 3. 0, 2. How do you get 3? Should be and time is not equal to 0 either. One and 3. We start at 0. If time is 0 over here, time is 0. IT minus okay. Okay is pref I plus T. Pref 0 plus T. Oh. Yeah, okay. One, two. Zero, 3, 3. 0, 0. If OK is greater than or equal to pref n minus 1. Okay. 0, 3. If it is 1, okay, let's see, right? If I is 1 over here, then we use IT. Um, we added 3. What we should have added was over here. Two, three, one. Um, so this is the time needed for the previous ones. IT minus prof began. Time equals star IT minus OK. Enter dot pushback n minus I. Oh, I think I know what's wrong. So IT. Um, and we should change this to F0. 0 to 1. Put extra 1. 20 should do everything, and then 4 over here, and then 5 over here. Okay. This is how much we need. Okay, would be time I minus um time task I. 1. How do we get to 1? Oh, we start over here. We start at tasks 0. 3. Task 0 minus time plus t. So 0 to 1, 0 to 0, 2, 0, 2. Alright, nice. Oh, it's just the harder version? Oh, this is, so you gotta do ON for this one. Okay. We can go back here. Let's see. So it's a bit different. You need to find it in O of N. Nums.length and nums. Okay, we have mod 2. We have even and odd. For a subarray, we want the ratio to be A and B. Okay. Let's see. X divided by Y is less than or equal to A divided by B. So X divided by y is less than or equal to a divided by b. And we also have x plus y equals L, right? Equals the current length equals L. Can we find a thing for x or something for y maybe? So we have L minus y less than or equal to a over by. So 1 plus a over by greater than or equal to L. Y is greater than or equal to b times L over a plus b. And then it just reduces to finding the number of y such that this is valid for a particular length L. Okay. So for every L, y has to be greater than or equal to that in order for it to be true. Then y has to be greater than 0. Okay. So let's write this down. We have y is greater than 0, y is greater than b times L divided by a plus b. Just find the number of subarrays such that find number of subarrays such that sum is greater than or equal to x. Okay, num range. This is okay. That's good. Um, b times L divided by a plus b. What do we do? So for every L, this is for every L. So every L, and then so this is n log n. This is n log n. Find the sum. Okay. So as long as these two are true, then we're fine. So b and a plus b, they're all constants. Don't think we need this. Alright, so first we gotta change everything in nums. And then we have L. What do we do with L? Well, I mean, O and squared solution is really easy. Is it binary search? So the sum of y can be between 1 and n. We have L must be less than or equal to a plus b over b times y. Number of subarrays such that length is less than or equal to uh, k times sum. X more than equal to a over b times y. Oh, so the number of subarrays such that, okay. Negative b. Now it turns into a times y greater than or equal to a times y minus b times x greater than 0. Number of subarrays with sum greater than 0. I think you can use you have value and you have number of subarrays with sum greater than or equal to 0. Okay, so this is the problem I'm trying to solve, basically. Yeah. Segment tree and binary index tree. Is it really? Is it something in code versus value? I don't think so. I don't think I've seen non-negative subarray. Find prefix sums. Count the number of variables. Okay. So return the number of inversions in this. Okay. Okay. Just use this one. Count inversions. And 10 plus 1 times 10 divided by 2 minus 7, 3, and 0. Does this count if y equals 0? If y equals 0, no. If y equals 0, x will always be negative, so it's okay. Oh, Wrong answer. Don't think. Don't think I did anything wrong. Um, I think I counted the ones where it's a bunch of X's in a row. Let's see. Zero. Three. Probably something wrong with the inversions. I'll just write the inversions myself. Let's see. 3. Let's see the one using order statistics tree. Where was it? It was over here. Inversion counting. Over here. Um, where could this go wrong? Let's go to stress tester. All right. Then I can do a brute using this. So over here, we have to insert a array. Yeah, this should be fine. So just gotta wait for it to. Okay, so it should be the number of inversions over here. So focus on this problem. Inversion count. What does inversion count do? So it counts the number of subarrays that have negative value. So that's what we're doing. We're counting the number with a negative sum. Okay. Why can't we just count the number of positive sum or non-negative sum? That would just be way better, right? You can just turn this. Okay. Yeah. Can it go out of long? 10 to the 9 times 10 to the 5. Nope, it can't. Yeah. We're counting the number with positive sum over here. If all of them are negative, um, if all of them are, if all of them are strictly increasing, let's see, right? So over here, +1, then +2, +3, so on. I mean, my stress test is always passing, but there must be some little test case that I'm missing. N times n minus 1 divided by 2. E times x less than or equal to a times y. Okay, so um, y a's minus x b's is greater than or equal to 0. Oh, so 0. Got 0. Okay, let's see. Um, that was a quick. That was really quick. All right. Oh, how do I get negative values? Oh, we're printing things out. I think, where are we printing things? Uh, so here. Wait, how did I get to those values? This makes no sense. Um, Oh, I see. We passed them as parameters. I don't know where my solution is wrong. Um, I think it's correct. All right. I'm gonna go over solutions. What it look like. So basically for problem one, let's see. For problem one, all you have to do is just brute force everything. So, problem asked, right? To choose a pair of distinct indices at and j, and you calculate the strength of them, and you output the maximum possible strength over all pairs. So in this problem, what you could do is you could just brute force, right? You try everything. So you try every pair for I 0 to n, and j is I plus 1 to n. You try it. Um, The new the strength of it should be nums I times nums j divided by GCD nums I nums j divided by GCD nums I nums j. Right, that's just what the problem is asking. So you can take the maximum of all of them in your answer, and you can return the answer. And you have to use long long. Yeah. Um, problem B. Okay, so problem B is the easy version of problem 4. So for problem B, you can use a sliding window-ish. Probably no, it's not. It's probably just a brute force. Um, so basically, it's asking you for how many subarrays. Um, y is greater than 0 and x divided by y is less than or equal to a divided by b. So you can just loop over every subarray. There's n, there's in all there's n times like n squared subarrays. You can just loop over all of them. So that's what I do here. For the starting point, I have x and y, and then for every index later on, you either increment x or increment y, right? If it's even, you increment x. If it's odd, you increment y. And then if y is greater than 0 and 1 long long times x times z, less than or equal to 1 long long times y times a, and answer plus plus, and then return answer. Problem 3. Problem 3 is basically a binary search on array. Binary search with prefix sums. So in this problem, what it's asking you to do is you have a bunch of shifts where people work, and then you have a bunch of tasks. At the start of every shift, you have the current task you're working on, and then you just do as many tasks as you can during that shift. If you do all the tasks during that shift, then you end the shift and you restart the task, right? And if you don't finish, you carry on to the next shift. So what I did, first of all, you gotta loop over all of the shifts. So start off with this. Um, I have I, which is the current task we're on, right? Current task we're on. I have time, which is the time needed to finish this task. Okay. And then now, for every timing shifts, we have our OK time. So how much time we can reach, basically. It should be task I minus time plus t. Uh, and then if I is greater than 0, we add prefix I minus 1. So what is prefix? Prefix is just a prefix array of the time needed to for a task, right? For example, pref2 would be the time to do task 1 and task 2. So you have our OK time. You use a upper bound in the prefix sums. Okay. First of all, if this OK time is greater than or equal to the time needed to complete all the tasks, then we can just restart the whole thing. So I is 0, time is equal to 0 or less 0 is fine. And enter dot pushback 0. Yeah, enter dot pushback 0 because we have 0 remaining. Otherwise, the current I will be IT minus prep begin. Time will be equal to bar IT minus OK, and enter dot pushback n minus I. And you can just return your answer array at the very end. Okay. I'll also go over my solution to Q4, which I don't know why it's incorrect. So basically, look, right, we have these two conditions. So the condition basically, let's look at the second condition, right? We need b times x is less than or equal to a times y. Now, if we rearrange this, you get b plus a plus the dot plus a minus b minus b minus dot 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 minus b. It's greater than or equal to 0. So over here you have ya's, right? And over here you have x negative b's. So basically you just turn the problem into finding the number of subarrays with non-negative sum. You change all of the ones with odd indices to a, and you change the value of all of the even indices to negative b. And then you just find the number of subarrays with non-negative sum. So what I did here, I calculated the prefix sums and then calculated not really the inversion, more like a consecutive, and then you return this count. So why does this work? Um, let's say you have a prefix sums of but I added 0 at the beginning, so 0, -1, 2, -1, -1, and 2, right? So to calculate the ones with non-negative sum, right? First, this is the prefix sums, all right? So, doesn't really work out. Let's see. If this is the updated array, this is updated array, and now we'll calculate the prefix sums. 1, 1, 0. Wait, this is right. 0 over here, and then -1, and then a 1. Okay, so this is the prefix sums, all right? Um, so now you just calculate the ones with non-negative sum. So basically, calculate the number of indices such that calculate number of pairs I less than j such that ai is less than or equal to aj. Because right when you subtract them, because aj minus ai will be equal to sum of I to j minus 1. This will be the sum of that, which is a subray. Okay, so you just calculate the number of pairs I smaller than j, such that ai is less than or equal to aj. Over here, I just use a order statistics tree to help me do that. Right, I use pairs because there might be duplicate values. I have the rest. For int I is 0, I smaller than n, I plus plus. The rest plus equal to t dot order of key, ai, and j. Right, and then t dot insert ai and j. And then you return the rest, and then you just return the CNT-pref. So that is Q4. Um, wait around There's a few minutes left. So yeah, that's my contest. I will solve Q4 later. Yeah, I'll see everyone next time.